Now, where were we? We were so rudely interrupted. I did not realize how quickly I was coming to the end of the video. So my bad. Here's our part two of section 8.2. Okay, so we're looking at graphing this thing, and we've got some points. We figured out that we can look at this parabola. The text calls this standard form. I'm probably going to refer to it as vertex form. We can look at this in vertex form and say, well, this is x minus 0 plus 0, right? X minus 0, where the a value is a negative 2. We know we've got an unhappy parabola. And so we know that the vertex will be at 0, 0. And then we plug in points. We plugged in negative 1, negative 2, got these values. We know that it's going to be reflected on the other side of the vertex or the axis of symmetry. And then so now I'm just into plotting points. So I'm down here at negative 2 on both sides. And then I'm down here at negative 8. And I know this looks wickedly crooked. Let me see if I can fix it a little bit and kind of twist it a little bit, and making my Y do a dance. All right, so that makes me feel slightly better. And then I've got this graph, okay? I'm going to do the same thing here. And with this one, my vertex is given to me as it was in the last problem. We had to observe it. The vertex is going to be at 2, 3, right? The vertex is at 2, 3. And if my vertex is at 2, 3, how do I get that from here and here? 1, 2, 1, 2, 3. Here's my vertex at 2, 3. It's a sad parabola again. It's going to have the same exact shape because the a value is the same. It's going to be out 1, down 2, out 2, down 8. Out 1, down, but not down to 8, down 8 from the point where we start. Let's see if that makes sense. So if I were to plug in some values, recognizing that my vertex is at 2, 3, I'm going to plug in like a 1 and a 0, and then play that out on the other side. That'll be 3 and 4. You get me on the axis of symmetry points that I'm looking for? So this is my x and my y. I already have this point there. If I plug in 1, 1 minus 2 is going to give me a negative 1. Negative 1 squared gives me a positive 1. Positive 1 times negative 2 gives me a negative 2. Negative 2 plus 3 gives me a positive 1. So then my answer is down here, right? I got positive 1. If I plug in that positive 1, it ends up being positive 1. Out 1, down 2. You see what I'm saying in terms of the shape? And then we have the same thing over here because I'm exploiting symmetry. So I got a 1 here and a 1 here. And so my expectation is that I'm going to go out 2 from the vertex and down 8. And so that should give me, if I go down 8, I'm going 1, 2, 3, and then 4, 5, 6, 7, 8. I should be down at negative 5. That's what I suspect will happen when I plug a 0 in there. So I plug 0 in. Let me do it with a little bit of work. 0 minus 2 quantity squared is going to be negative 2 squared, which is going to be a positive 4. 4 times a negative 2 gives me a negative 8. Negative 8 plus 3 gives me that negative 5 we suspected. So I'm going to go down to negative 5. 1, 2, 3, 4, and 5. So here we are at negative 5. That's where this point will be. And then we can extrapolate that this point will be here too. And so boom-tastica. Okay. Just make your points bigger when they don't hit. Boom. Wow, that was pretty bad. But you see what I'm doing. You have very neat handwriting, and you're a wonderful human being, and you're not going to make your graph as terrible as mine. All right? So this is what we're looking at when we graph in this form. And now we're going to talk a little bit about some of the information that we have here. So if you want to know something about the geometry of the physical characteristics of your parabola given your equation, you need to recognize this stuff here. So first of all, it's really important that we have our equation in vertex or standard form in order for us to find some information. So if we wanted to find, let's say focus, the focus is going to be the same x value as our x function, as our vertex, but the y value will be located, check this out now, plus 1 over 4a. So you know what this a value is? You take 1 over 4 and you multiply it by a, and you're going to add it to whatever direction you need in order to find where your focus is. So you might be adding it or you might be subtracting it if it's a sad parabola. And that'll come in the fact that A would be negative or positive, okay? And it says that the endpoints of the lattice rectum are 1 over 2a units from the focus. So that's kind of another neat thing. So these values are going to be, here's the focus. These values are going to be 1 over 2a distance from the focus value, okay? So this is important stuff that we're going to hold on to because it's going to help us find the focus. And also, if the focus is k plus 1 over 4a up, or 1 over 4a units up, then the directrix has to be 1 over 4a units down from that vertex. Does that make sense? Because remember, we said earlier that the focus and directrix are equidistant from every point on the parabola, including the vertex. So it makes sense that that's the situation we have there. So here's a visual breakdown of what's happening in this situation. We have the form of the vertex, the form of the equation. So notice this, I need you to watch this. Y is equal to a times x minus h quantity squared plus k. This is for parabolas that we're used to. Happy ones and sad ones. But then we have a whole other host of parabolas that we can talk about, and hopefully we'll get a chance to look at some examples of this, if not today, then a later time too. We're going to talk about parabolas that open to the right, and that's when a is positive, a is greater than 0, and open to the left, that's when a is less than 0, okay? In each of these cases, the way that the equation is written, y minus k plus h over here, when we're changing, it's kind of like inverse functions in a way, right? Y minus k plus h, hk is still the vertex, but the orientation is a little bit different. Notice that y is always associated with the k is always associated with the y term, and h is always associated with the x term. In this case, since x is the overall function, we just add that on. Here, the axis of symmetry is going to be the first term of the, oh, that's weird. Do I buy this? Y equals k. Yeah, I guess so. So it's going to be the first term in that equation here. The axis of symmetry is going to be given here. It's going to be y equals k. Because if I have, think about it this way, if I have a parabola laying on its side, a y equals k equation would make sense to be the axis of symmetry, no matter which way it's laying. The focus is given here. The directrix is given here. Right? Remember we said going down from the vertex values, and this would be going to the left or to the right of the vertex values. It's a little bit weird. I have to be honest. I don't think about this until I teach it. The parabolas I think about all the time in terms of the y equals ax squared plus bx plus c. That makes sense to me. I even think about vertex form, but all of this information about the focus and directrix, I don't think about it that much because it's not something that I talk about a lot. So I know that memorizing this and keeping this information straight in your mind will take a little bit of time, but just take the time to do it. If you like this picture, I can send you a black and white copy of it so you can, have it printed out, or you can, take a snapshot of this and keep it somewhere on your desktop or something like that. All right, so these are, and this is the lattice rectum, will be 1 over a units. This is going to be important for us to process through some problems, okay? Let's look at some more examples. And real quick, before I even finish posting all of this video, I found another video that I wanted you to take a look at, and it is posted in your assignment sheet, I believe. I am trying to figure out how to get there. Let's do that. Let's do this. Nope, wrong class. Okay, so here I have this video, and I'm about to post part 2 after I'm done this video. It's cool to learn from other teachers. It's a nice video that actually kind of gives a better visual representation of some of the stuff that we're seeing. So it's not like extra work, but it is a few minutes. You can fast forward it or listen to them on fast. But it's a good video, and it's better than I'm presenting the information kind of in 2D. He kind of talks about it a little bit better. Okay, so with that, let me go back to what we were talking about. Graphing an equation not in standard form. So what we're going to do is put it in standard form or put it in vertex form. And to do that, we are going to, we've done this before, right? But look at the term here. The term is that the y term is squared. Okay, and we're going to put it in standard form, but we're going to put it in, let me try to make sure I can do it, x equals a times y minus k quantity squared plus h form. So let's see what we can do. We're going to isolate the x term, get that on one side. So I have 4x is equal to y squared, which is equal to, y squared plus 2y plus 13. That's me just kicking this over to the other side. What I'm going to do now is move the 13 over, and I'm going to factor out the 4. I know this sounds crazy, but just check me out. 4x minus 13 is equal to y squared plus 2y. And then now I can complete the square over here. I'm going to factor out the 4. Watch this. When I factor that 4 out, I get 4, and then I have x minus 13 over 4. Okay, is equal to y squared plus 2y. Now to complete the square, I've got to add a 1. When I add a 1, let me add a colorful one. When I add 1, remember half of the b term quantity squared, I'm going to add a 1 over here, and I'm legitimately adding a 1, but I want to put it in the parentheses here, so I'm not really adding a 1 as opposed to adding a 1/4 inside the parenthesis. I'm going to let you think about that for a second, and you'll see the reason why we do this. So when I simplify this side, I get y plus 1 quantity squared, which is part of what we're looking for. This x being multiplied by 4 is weird, so we got to get rid of that thing. So watch how this happens. Instead of having this as a plus 1 on the outside, I'm going to add a 1/4 on the inside. Because if I distributed that, I'd still have the 1. And so now I'm going to simplify this. So I have 4 times x. Now this plus minus situation is a 12, right? Minus 13 plus 1 gives me 12 over 4. 12 over 4 is 3. So I get a minus 3 equals this. And now I'm about to bring it home. I'm going to divide both sides by 4. So I have x minus 3 is equal to 4 times y plus 1 quantity squared, and bring it to the standard form that the text likes. X is equal to 4 times y plus 1 quantity squared plus 3. I'm not going to do another video after this, right? I think we have one more example, and even if I don't get through it, I won't make this a 3-parter. You have enough information. Let's graph it. I just know this is taking long. I feel bad, but that's okay. Good topics need a little bit more time. That's all right. Okay, so now we're going to find the vertex and we're going to graph the thing. So a couple bits of information. One bit of information we had here is that did they ask us for the direct? No, they don't ask us for anything. So one bit of information is that we've got the vertex is at HK, and so the vertex is going to be at 3 positive, 3 negative 1, 1, 2, 3, negative 1. All right, at HK. So you can see that HK, H, and K minus the K, the opposite of the K in a sense, HK. So 3 and negative 1. And then the next thing we're going to do is figure out which way it's opening. Since A is positive here, and I had this last time, when A is positive, we're opening to the right. When A is negative, we're open to the left. And so since we're opening up to the right, I expect everything to be going this way. So I'm plugging in values like a 0 for y in order to see what the corresponding x term is going to be. And for me, I see that I've got this 4. So instead of going out 1, up 1, I'm going to go out 1, up 4. So I expect my point to be 1, 2, 3, 4 units up here. I expect it to be 7. Well, let's go ahead and check to see. So remember, the axis of symmetry is now a horizontal line like this. And I'm going to exploit symmetry like last time. This time I'm putting in a 0 for y. So 0 plus 1 gives me 1. 1 squared is 1. 1 times 4 is 4. 4 plus 3 is 7, like we said. So 1, 2, 3, 4, 5, 6, 7. I have this point here. I'm going to mirror it down here when y rather is equal to negative 2. Boom, I got that point. The next thing I'm going to do is go up, and if I plug in 1 for my y value, I'm going to get all the way up here at 19. And I'm going to have to hurry up the video. And then I'm going to exploit it on this side as well. So you end up with this very narrow parabola here. I hope this makes sense. Do what you can up to the information we have. Let's talk live so we can make things a little bit more plain.